All right, so for those of you at home, you should have these notes in your notebooks already. Remember, topographic show geographic features like hills and valleys. Contour lines show elevation. Contour interval is the distance between the contour lines, and you find that on the map. It's part of the legend. All right, so with this one, the elevation of point A it's not exactly 300, because if it was, it would be on the line. So it must be more than 300, but it must be less than 310, because the contour interval of this map is 10 feet. The contour interval, what is the contour interval? So from 100 to 200 is 10 lines. Remember, every fifth line is bolded. So that's 5 more, so that's 10 lines. 100 feet divided by 10 feet per line means it's 10 feet per line. If we look at BC, these lines are very close together. These are farther apart, so this is more steep. Walking from E to D, you are going uphill because the elevation is increasing. All right, and then you should have these notes. So if you need to pause the video, you can pause the video and get those. All right. These lines that look like they're almost touching, they're so close together, that's very steep. That is a cliff. This is another cliff. This is also a cliff. Anytime you see contour lines that kind of go around the same thing, that's going to be a hill or perhaps a mountain. So here we have a hill. This is a depression. These little marks are called Hatcher lines, so that is a depression. Here we have river valley. Now there's not a river there. If there was a river, there'd be a blue line running through it. But there must either occasionally be a river there, or perhaps there used to be a river there, and it's carved out this valley. And so as the contour lines,
Are you done with your attention?
I am not.
May I have it, please?
I have not done it at all.
Oh, well, I'm collecting it.
Okay.
Come back.
I can give me like
I'll just,
a couple
you're okay.
minutes. Okay. So the contour lines point towards uphill, towards the source of the river. So then we have these questions. I believe everybody has had a chance to do these. Contour lines create so everybody should be looking at their notebook now. The computers should be off. Okay. You should be looking in your notebook. Contour lines create a group of concentric closed loops. Which of the following features could this indicate? So if they're concentric closed loops, we're talking something like this. Now they might be more oval, but something like that. So what is that going to be? Yes, ma'am. Well, that's something you could have thought about during homeroom. Hurry up. If you need to use the bathroom, go ahead and use it so that you're not leaving twice. So if I have closed concentric loops, what do I have? Is it a stream channel, a hilltop, a depression, or a cliff? Yes, ma'am. Yeah, it'd be a hill. Okay. A depression, remember, a depression would look like this. It would have those little teeth, those Hatcher lines. A cliff would be very close together lines. And a stream channel would be those V-shaped lines. Yes, sir.
Right.
You should already have this answered, I believe. If not, then yes, I would be writing down the answers as I go over it. Describe the pattern on a topographic map that would indicate a stream valley. So again, it would be that kind of V-shaped contour line. Okay? So that lets you know that that's a stream valley and that there'd be a river running through it. Okay? And the valley always points uphill, so that means the river is going this way. This is uphill, this is downhill. On the topographic map, 5 contour lines are very close together in one area. The contour interval is 100 feet. So that means from one line to the next line is 100 feet. What feature does that indicate? How high is this feature? All right, so you have 5 lines. They're very close together. It says 3, 4, 5. It's 100 feet. So then that's 1, 2, 3, 4. That's 400 feet high. And so what would you call that? It's extremely steep. Okay? It's very, very steep, and it's 400 feet high. Yes, ma'am. Yeah, it'd be a cliff. So you might be down here, and it might look like that. Okay. Now you could be on a plateau. This could be another cliff. Right? But this part right here is what we're talking about. That's 400 feet high. On a topographic map, describe how you can tell a steep slope from a shallow slope. If it's a steep slope, they're going to be very close together. Right? Because that indicates that your elevation is rising in a very short distance. If they're farther apart, right, then you're increasing elevation on a much longer horizontal distance. So how can you tell the difference? How close the contour lines are to each other. The closer they are, the steeper it is. On a topographic map, a river is shown crossing from point A in the northwest to point B in the southeast. Point A is a contour line of 800 feet, and point B is a contour line of 900 feet. In which direction does the river flow? On the topographic map, a river shown crossing from point A in the northwest to point B in the southeast. Alright, so I'll go back to that. We got point A in the northwest. We've got a river going to point B in the southeast. This is 800 feet. This is 900 feet. Which one is higher, 800 or 900?
900.
Right, so this is uphill. This is downhill. So that means, does water run uphill or downhill? So it runs downhill towards point A. So the lesson there is, don't think that just because the line is to the south, that the river is going down that way. You can be going downhill towards the north. And you'll actually find that, alright, I'm going to make an ELA connection for you. In some writings, especially older writings, you'll find that they go up to the north and they go down to the south, which is possibly a subtle way of them saying the north is good and the south is bad. And I'm not just talking about America, I'm talking about other countries too. So, anyway. I mean, think about it. You don't go down to Charlotte. You go up to Charlotte. It doesn't matter where you are geographically located to Charlotte. You go up to Charlotte. Right? You go uptown. Yeah, me and my baby, we're going uptown tonight. Alright? No one wants to go downtown, because who wants to go down? Alright? I'm just saying, some people think that way. And some people think that way subconsciously. They don't know they're thinking it. On a topographic map, 6 contour lines span a horizontal map distance of 0.5 inches. The horizontal scale is 1 inch equals 2,000 feet. Well, if 1 inch on the map equals 2,000 feet on the map, on the real world, how much does half an inch represent? Alright, time for a math connection. Is over up, right? So 1 inch represents, actually that's percentages, never mind. So 1 equals 2,000 feet. 1 inch equals 2,000 feet. That's your ratio. So you're going to set that equal to the other ratio. 0.5 inch equals X feet. Right. So you cross multiply. 1 inch times X equals 1,000 feet. Inch, because you multiply the handles too, or the units. Then you divide both by 1, and X equals, the inches cancel out, and so 1 inch equals 1,000 feet. It's math. Also, you could just say this is half, 0.5 is half, so then 2,000 is 1.5. Okay? You not have your notebook? Yes. You have it out? Where you can write things down? We have a quiz tomorrow and a test next week. Alright. So any questions about those? Oh, how far apart are the first and sixth lines? Well, that's kind of ambiguous. The 6 contour lines span a map distance of 0.5 inches. Oh, I see. So, yeah, they're 1,000 feet apart in the real world. Yes, sir. For number 4, how close the lines are. So when the lines are really close, it's really steep. If the lines are farther apart, it's not steep. So think about it this way. Let's see. So here's sea level. I have this side and this side. Here's a contour line. Here's a contour line. Here's a contour line. Each contour, the contour interval of this map is 1 block. Okay? If you were standing over here, there's not a lot of horizontal distance. In fact, let's see here. From here to here, you're going to go up 3 blocks before you go over 1 block horizontally. So that's a lot of rise and a little bit of run. Over here, it's almost 1 to 1. You go up 1 and over 1, up 1, over 1, up 1, over 1. So the slope of this is 1. The slope of this would be 3 over 1. So that's a very steep slope. The lines are closer together, horizontally speaking, and these are farther apart. Now that brings us to satellites and computers. Did I give you this to glue in yesterday? Or the day before yesterday? I did not? Okay. So we'll go over it real quick, and I got some other things to hand out, although we're not going to have time. All right. A satellite is a small object that orbits a larger object. Global Positioning System is your GPS. Geographic Information Systems use exact geographic locations from GPS receivers, and spatial information to create maps and images. So for example, this is a geostationary orbit. So this satellite, so let's say this is the Earth and this is the satellite. They're rotating together, okay? So the Earth and the satellite are going at the same, the Earth is rotating at the same speed that the satellite orbits. So it's always over the same spot. So it's geostationary. I can't even comprehend the math that goes into that. Okay? A polar orbit, so again, if my fist is the Earth, as the Earth is rotating, the satellite is just orbiting from north to south and south to north and north to south. So in a day's time, it can scan the entire Earth. Not all at once, but one strip at a time as the Earth rotates. This is a map made using a geographic information system. And we have those, but we'll pause there. All right. So tomorrow we have a foldable that we're going to do. But before we do that, if you have your own glue stick, if you get out your glue stick. These are the notes. Okay. So those of you at home, you can go back to the notes and pause and get the notes.